Okay, let's continue with examples on the while loop. Consider the following setup function that includes a while loop. We have a float x, so let's start by drawing the memory diagram. So, setup. We have float x, which is garbage to begin with because it doesn't have it hasn't been initialized. Then I have x equals random. So here, instead of assigning a variable, assigning a number to x, I am actually assigning x to the output of the random function. This is to make this setup function more interesting. So the random function, please look it up at processing.org in the references section. Random function, it has different forms. In this particular form, we're simply giving it an interval. The interval is between 1 and 12. And basically, it randomly selects a real number between 1 and 12 each time that it runs. So this is to keep the input of the program random. I could have also asked for user input, but the program would have just been a little bit more complicated. As you know, taking input from the user, that is like numbers or numbers from the keyboard, is not trivial. So this random function generates a randomized float each time. So let's assume that the first time that this is called, this function is going to generate 5.5. If it does that, and you can go ahead and run this program, you'll see it's random, it's all by chance, right? So any number could be generated. So let's say 5.5 is going to be generated. This is actually our initialization expression. So this is just like saying int I equals 0. When we initialize I, this is the same thing. This is our initialization. We're going to go into the loop. So we say that it is a condition while x is greater than 1 and x is less than 10. So it's a logical expression. In this case, it's true because x is greater than 1 and it is less than 10. So there is an and here. So it means that both of these need to be satisfied, as you recall. So then let's start my console down here. So what's going to be printed is x, which is 5.5, is in range. And we'll go to the next line. Then this is our updating. This is our updating expression. So you see, it's non-conventional. Usually we have I plus something, but this here is assigned to another random function. So this is the updating expression, because if this wasn't here, x was set to 5.5, and this would become an infinite loop. Here, something else is generated. So let's say the first time we run this, 9.1 is generated. So the value of x actually changes and it becomes 9.1. Okay, so we're going to loop back up now. We say while x is greater than 1, it is, and x is less than 10, which it is. So we're going to say 9.1 is in range. Let me stay. Okay. Then again, we are here, and let's say this time randomly it's going to get 10.5 or even 10. So right away x changes to 10.5, and we go back up. X is greater than 1, that's true. And x is less than 10, that's not true, that's false. So we're actually going to get out of the loop and go to the statements that are after the loop. So what's after is number. So this is going to be printed out. Number x is 10.5 is out of range. And with that, if there's nothing else to the program, then the program terminates, and when you execute the last statement in the setup function, the function dies and goes out of scope. Basically, how this function works is, let me take these out. The program keeps running as long as x is between 1 and 10. And it stops when the number is out of range. But as you see, you have your three things. So you have your initialization, you have your test, and you have your update. So these are the three things that each loop needs to have, and you have your statements that you execute inside of that loop. So hopefully that's clear to everybody. Let's do a quick question. Okay, let's look at more while loops. So what is wrong here? We have our declaration, we have our test condition, we have our statements, and we are updating our expression. So why is it that this program wouldn't run? Well, think about it. Maybe pause the video, make sure you get it. These are really important that you're able to pinpoint what is wrong with this statement. So I is not initialized. It doesn't hold a value. It's unknown. So when you say I less than 5, that is that's an error, because I is actually garbage. So this you cannot do this. This won't work. Let's look at another one. Setup I is 0, I less than 5, and I minus minus. So your statement is that as long as I is less than 5, go ahead and print out I and then I minus minus. So what's wrong here? Let's see. So if we were to draw the memory of this setup function, I is set to 0, and we say print I. So we print I over here, let's say. We print I is 0, then I minus minus. So this I will become minus 1. Okay, so we go back to the top. I is minus 1. Is it less than 5? It is. So we output minus 1. Again, minus minus. Minus 2. We go back up. Is I less than 5? It is. So we print out I. And so on and so forth. So you see, we will never approach 5. I is always going to basically decrease, and it's going to decrease as long as you run this program. So this loop is wrong because it's going to be an infinite loop. Although I should mention that it's not exactly an infinite loop. It's going to run until I gets large enough, because it's going to be negative millions and billions or whatever. It's going to run until you get what is called as what is referred to as an overflow, and I have that in the slides a little bit further. Basically, when the variable gets too large, and it gets too large for an integer to contain that variable, then a crash happens. So this is a very serious problem indeed. All right, well, what is wrong here? So you have while int I is 5, and you want to execute this while I is greater than 5. Well, first of all, what do you think is the output? So I set to 5, and this keeps on getting bigger and bigger. So the same problem as we had before, the condition will never realize. So this becomes an infinite loop. It keeps on going and going and going. So the exact same problem as before. What is wrong here? Well, the issue here is having a semicolon at the end of while. What happens is, this is the do nothing statement, as you recall. So the semicolon causes the loop to have an empty body, right? It'll have an empty body, and this is actually going to be another very, very dangerous infinite loop because it's really hard to predict. It's really hard to detect. Basically, what happens is this is all it's gonna run. So it basically, this down here actually is equivalent to as if you had while I is greater than 0, like that. This is equivalent to having something like that. So it's going to run forever without anything in its body. So it's kind of like if you remember when I gave you an example that was while true, and this would also run forever. So this is very bad. This is very bad, right? So yeah, just make sure you don't put a semicolon there. So let me just erase here. So I in I greater than 0 never changes, and there is no output. There are other cases where you put a semicolon at the end, and if the condition is not realized, it completely ignores the block. So putting a semicolon at the end of a while condition is a very, very dangerous thing. So what is wrong here? We have year set to 1, and we check to make sure that we're going to keep looping as long as y is less than and equal to 20. So that's what you want to think of in these loops. You want to keep looping as long as the condition is valid. So we're going to calculate balance based on this formula and assume that balance and everything else has been set and initialized above. What is wrong is we are not incrementing year, so year is staying constant. So year plus plus needs to be inside the while loop. So this is an infinite loop because year is not updated in the body of the loop. So forgetting to update the variable used in the condition is common, so please make sure to avoid this because it would cause an infinite loop.